Hi, my name is Kerry Holzman. I'm the co-host of a free podcast called Tech Vets. It's available at www.tech-vets.com. Tech Vets is just short for Veterans of Technology because myself and my good friend and co-host Mike Smith have well over 20 years of experience in the IT industry, and we each run our own businesses on opposite ends of the country. I'm here in Arizona, Mike's out in Pennsylvania, and the way we approach our businesses is completely different. So if you're thinking about getting in the business, you're already in the business, or you're in any business really, that you're self-employed, you can take away some of the tips, warnings, and our experiences that we share, our tales from the trenches, everything from taxes and other paperwork to dealing with difficult customers, setting customer expectations, dealing with late payments, etc., etc. And we run the show about once a week, sometimes once every other week, depending on our schedules. It's completely free, and I think that if you enjoy my videos here on YouTube, I think you'll enjoy my podcast as well. So check it out, it's free. What have you got to lose? Now it's time to begin the build that a lot of you have been really looking forward to, utilizing this gigantic Cosmos 2 Ultra Tower case from Cooler Master. This thing is huge. According to the box, it weighs 26 kilograms. That's empty in the box, which is right around 58 pounds. And look at this thing. I mean, sitting on the counter, it's taller than me. Of course, that's not really saying much, but trust me, it's still a big case. Now, what parts are we putting in this bad boy? Well, we're putting some amazing parts in here. Let's start with the, you know what? Let's not. I'm sorry, something's not right. You know, since I walked in this room, there's like a disturbance in my schweng fei. I can't explain it. There's just something that's not. Oh, ha ha. Very funny. No, I don't think so. I gotta take care of this. I'll be right back. All right, you know what? Enough of that. Double up. Yeah. I feel a little better. You know, speaking of my love of Coca-Cola, one of my viewers just sent me this Coca-Cola sign. How cool is that? So Zeke, if you're out there watching, thank you so much. I really appreciate it. This looks like, I'm not sure how I'm gonna mount it. It looks like what they put on the fountain machines, you know, when you go to the restaurants and you have to get your own drink. I think that's where it comes from. But I gotta find a place for this. I'm just gonna stick it right here for right now. Now know that I don't have any paid sponsors, so when you see goofy stuff like that, that's just me being a nerd. All right, so I don't want you to think for a minute I'm getting a dime from Coke. It's quite the other way around, I assure you. Coke's getting a lot of money from me. But anyway, let's get on with our build. So let's talk about the parts we're going to be putting into this monster case here. Start with the motherboard, which is right down here. We've got an Asus P9X79 Pro. This is about a $310 motherboard. I mean, we're not screwing around on this build. It's a great motherboard, and the owner of this computer was actually getting ready to buy his board, and he almost bought an ASRock board. And I was like, dude, just no. All these other parts are so high-end, don't go cheap on your motherboard. ASRock, you know, if you're on a budget or whatever, it'll do in a pinch, but stick with Asus or Gigabyte, and that's exactly what he did. And this is a socket 2011 board. So the CPU we're using, which is way over here, if I can reach it, this is the Core i7-3970X. This is interesting. I've not seen a retail box CPU that does not come with a heatsink fan. And this one does not. It's the first time I've seen that. And this CPU is $1,000 just for this little chip right here. Why is this such a monster? Well, he's going to be using it for video editing, so he needs the speed as much as possible, and even then he'll probably still want a little bit more speed. And we're going to combine that with the RAM here, and this is 32 gigs of PC3 19200. It's a kit of 4 8-gig modules. This is the Mushkin Redline series, so not cheap stuff. We're going to keep the CPU cool with the Corsair water cooler, the H100i that you see there, and those are about $100 now, so they've come down in price. And for a hard drive, he's got the main boot drive to be an Intel to 480 gig solid state drive. That thing was close to $1,000 back when they were introduced. Not sure what they sell for today. I think that particular model might be discontinued. As is the video card we're using. I think this model's been discontinued too. This is the GeForce GTX 680. I want to say that's somewhere between $400 and $500 on the video card. Power supply is a gigantic 1250 watt SeaSonic. That's about a $250 power supply, by the way. Combined with a Blu-ray player. This is a Pioneer. This is about $85. And Windows 7 Ultimate, which we have right here. And then what he also wants is 2 regular hard drives and a RAID array. So he's picked up some Seagate Constellation Enterprise drives. These are about $200 a piece. They're 2 terabytes each. And we're going to configure these into a RAID 0, which combines the 2 drives into one large drive. And then each drive does half the work, which theoretically gives you twice the performance. It doesn't exactly work out that way, but that's the idea behind it. I've talked about RAID in a previous video, and I'll put a link to that if you want to learn more about what RAID is and how it works. The danger of running a RAID 0 is, in exchange for that performance, if either drive should fail, he'll lose the data on both drives. So it's important, if you're running RAID 0, that you run a regular backup of anything that's important to you. Now, with the introduction of the parts out of the way, it's time for me to get to work. So let me clean up this counter and get it ready for us to work on, and most importantly, let me get this case out of its box. And I don't want to film myself doing that because I'm sure it's going to be quite humorous. So I'll be right back. All right, so as you can see, I've got the case out of the box, and I've left some of the components out that we can install first, which is our optical drive, hard drives, and power supply. Those will be the easiest things to install and get out of the way. Now, once I get everything installed in this, I have no idea how I'm going to pick it up and get it off the counter, but we'll cross that bridge when we get to it. Let's take a minute now and look at some of the features of the case. Now, looking up here at the very top of the case, we've got our headphone output, microphone input, there's an eSATA port, 2 USB 3s, 4 USB 2.0s, and what you may not see is way up here on the top, this part kind of moves forward and back, and then all your lights and your power switch is all right up here. I don't know exactly why they covered that up. Maybe to hide the lights or to protect the buttons, I'm not sure. But that at least is better than a case store, in my opinion. I don't think that's as likely to break off. You'll see we've got these bay covers here that just come right off. And then we've got 2 hard drive trays that are removable that have a key to lock them in place. So we'll probably go ahead and utilize these for the this RAID 0 configuration, so that if one of the drives does fail, he'll be easily able to remove that and replace it. Let me put this back. Now this bottom panel also slides straight up like this to cover things up for a cleaner look. Again, I still like this better than a typical swinging case door. The cases that come with case doors I try to avoid. I've explained that in the past. They often break off, and if a case door swings to the left and you put your computer on the right side, it gets in the way of accessing anything you've got up front on the front of the computer. So having a case door like this that slides up and down is pretty nice. It looks like it's got a little magnet on the top here, and that just kind of grabs it and holds it in place. It's a nice touch. Now looking on the back of the case, we've got 10 slot bay covers here for accommodating a very large motherboard. We've got our cutout for the I/O shield, which is of course needed. Every case is going to have that. Got some grommets here for, I suppose if you've got a custom water cooler, you could use those. Power supply mount is down here. And then the covers are a toolless design. It looks like you just push down on the lever, and then the side panel comes, oh look at that, the side panel just swings open like the door on a car. That's pretty cool. We'll grab the other side and let's open the other side up. Now if there was ever a time to be intimidated by cabling, I'd say this is it right here. This big old bundle of cables right here has all of your fan connectors, your front port switches, I/Os, as well as the removable drive trays are all hardwired in, and they just got them all wrapped up right here. But don't worry about that, because we won't get to that till much later anyway, and it's not as big of a deal as it may seem. But if you look at how many fans we've got, I mean, my gosh, there's a fan up here. We've got 2 fans here, which I guess are going to come out. There's a fan up front, a large one. And there's probably some more down under here. We've got some documentation, more documentation, which probably goes over a lot more features of this case than I've done here. This is the first time I'm seeing this case, so you're getting my first impression of it right now. There are some removable drive trays here, which is a nice design. I really like the way those come out and go back in again. And we've got 2 boxes of parts. That's interesting. What do we have in here? Let's take a look and see what they give us. We got a thumb screw. I don't know what this is. We've got a couple of rails for something I don't know what for yet. And we've got a Ziploc bag with some nylon zip ties, it looks like. Lots of them. And wire holding clips. A couple of power supply adapters. And of course all our screws and the keys for locking and unlocking those removable drive bays up front. So that's in that box. And we've got another box over here. All right, so let me open up this one and let's see what we got in here. It looks like it's the exact same thing. We've got more screws and keys. I don't know if maybe they might have double packed this by mistake and it was only supposed to get 1. I'm not exactly sure. But it looks like he's got 2. Now, I'll make a disclaimer here that this case was purchased directly from Cooler Master as a refurbished case, scratch and dent type thing. And there doesn't seem to be a thing wrong with it. So I'm pretty sure we're going to have some extra parts. That's okay. Rather have extra parts than not enough parts, that's for sure. Now one of the other things I just realized on this case is there's a little latch right here, and we grab that, we can open that up, and look at this, there's room for some more drives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now a couple good things about working on a case this big is that you're not going to have the cramping issues or heat issues that you have in like a mini ITX case. It should run nice and cool, and it should be plenty of room for us to get our hands in there and to work on it, you know, whether we're initially building it or working on it in the future for any repairs or future upgrades. It should be a pleasure to work on this case. Now the first thing we can install very easily is our power supply. Again, this is a SeaSonic 1250 watt power supply. It's a pretty serious power supply here. The way the box opens, it just kind of swings open like this, and inside you'll see we've got a bag of cables here that comes out, and underneath the foam we've got our owner's manual, warranty information and support. We've got some nylon zip ties and some screws and a sticker that I guess if you put the sticker on your computer, it'll make it go faster. And what I thought initially was a bottle of Crown Royal is actually our power supply in this crushed velvet bag here. Whew, that is a beauty though, isn't it? Look at that. And like the other SeaSonic power supply I worked on a previous build, they've got the writing facing up here and the writing upside down here. Unless you turn it around this way, and then the writing's right side up here and upside down here. But it's right side up here. I don't know what they're thinking. Got a gigantic on-off switch. That's pretty cool. I like that. All right, let's get this thing put in the case. Now, if you're wondering where the cables are on the power supply, this is a modular power supply, meaning on the back here, you're only going to plug in the cables you need, so that prevents having to tie up all these excess cables, which, you know what, in this case, there's plenty of room to tie up excess cables. But, hey, you know what, if you're going to spend the money, you might as well do it. How much money? Well, I guess I didn't get to that in the beginning. There's about $4,000, pretty close to $4,000 worth of parts in this build. So you definitely don't want to cheap out and put a $20 power supply in here. And the owner of these parts most certainly did not cheap out, that's for sure. So the modular power supply is going to be very easy to install because we don't have to deal with pinching any cables or getting the cables fed in like we do with a typical power supply. And then the screws that I'm going to use the ones that came with the power supply. Some power supplies come with their own screws, some don't. You can use the ones that came with the case, it's fine. Generally, when a device comes with its own screws, I prefer to use those screws because sometimes there are issues with the length of the screw on some devices. It's not going to be a problem with the power supply. This is just kind of a formality. I could just as easily go through the big bag of screws that came with this case and find basically the 4 seam screws this power supply came with. They're pretty standard. In this build, I'm going to be using my Panasonic EY7410 electric screwdriver. I just love this bad boy. It's just, can't say enough good things about it. If you have to buy one electric screwdriver and you're going to use it a lot to justify the cost, this is the one to get right now. Now check out how easy it is to install the power supply in this case. I don't even need to open the side panels up. There are just 4 thumb screws that hold this bracket in place. We're going to take those out. Now just take your power supply, make sure you got it oriented in the right direction. I want it with the intake fan, which is here on this side. I want this down so it'll draw air in from the bottom of the case, bring in cold air from outside. And you just take this bracket we removed and it's going to fit right over the top like that. Then we're going to take those screws and put one in each corner. Now we just simply pick up the power supply with the bracket on it and slide it right back on. And we're going to put those 4 thumb screws right back in. Now the screwdriver that I'm using has an auto-off clutch, which means when it hits the torque setting I've set for it, you'll hear the screwdriver turn off. I've currently got the clutch setting set on 3, which you can just see right there. And that ensures that none of the screws are being over-tightened or for that matter, under-tightened. Now how's that for about the easiest power supply install ever? Now with our power supply installed, the next thing we can put in very easily will be the Blu-ray drive. So I need to open the side panel up again. So I just push that lever down and you'll see the side panel opens. And let me just turn this so you can see it a little better. Now, the side panel here actually has a couple grooves on the top. And if we grab those and lift up, or just hit it from the bottom, you can see the whole panel can come off, which is going to make filming this a lot easier. But it's nice that the panel comes off like that, and you can see just how thick this panel is, which I imagine is going to result in this computer running very, very quietly. You can also see there's some holes, if I can hold it right, back up. I really have to back up to get this thing on the camera. That you can mount a couple of 120mm fans right here if you want to bring air in and blow that onto your video card. That'd be about the right place there for that. We won't be doing that on this build. He won't need it, but just nice to know that it's there. Now we can actually mount the optical drive in any of these 3 bays here. I like to choose the top one. I think that's where it looks best. These are super easy to remove. Just put your finger behind the latch and then just pull it straight off. Go ahead and put this away somewhere. You never know in the future if you might want to remove the optical drive at some point for some reason. Maybe in the future we don't use them, which I'm sure will eventually happen. And this case is going to last a really long time, so you want to have that as an option to cover that back up should you decide to remove the optical drive out at any point. So here I've got our optical drive. Let's see what we get in the box. If I don't drop it on the floor, that would be helpful, wouldn't it? What do we have in here? Got a little bag of screws. That's good. We've got some warranty information. We'll set that right over there. And then right inside here, you can see that. See the drive's packed pretty well in there. Pioneer's not screwing around when they pack their drives, that's for sure. I mean, I've seen hard drives that aren't packed that well, and this is nowhere near as fragile as a hard drive. And then inside we've got the drive itself, some more documentation, and there's something else in this box. There's a CyberLink Media Suite disk, which I'm not going to install, but I'll give it to the customer if he wants to put it on. And that's all there is for that box. Now installing this Blu-ray drive is very simple on this case. You just slide it into the front until it's flush. And on the side here, you see that you've got these basically like little buttons. And if you just line it up right, you should be able to push the button in and it locks the drive into place. In fact, by pressing these in and out, it's hard to tell if it's locked or not locked. You're not going to know. So if I press it again, I can release it. And you'll see now if it's locked, the drive won't go all the way in. It'll stop about, I don't know, about a quarter of the way in, it stops. So just press that to release it. Don't force it. So if the drive's not easily sliding into place, this may be in the locked position. You just may have hit it by mistake, or it may have happened at some point. And then again, don't force this in. If it's not going down, that means the drive's not lined up right with the holes behind it. So just move the drive in a little bit and then it should just click right into place. Very easy. Now, even though I'm not going to be shipping this computer, and thank goodness, because it's very heavy, I can't even imagine what that would cost to ship. I do have to deliver it to its owner who's way on the other side of town. So I'm not comfortable just having the optical drive held in with the toolless design. On the other side of the case, there is a place for 2 mounting screws, which are completely optional and up to you, but I'll feel better securing that drive in with the screws, knowing that that drive is not going to budge. And it's very easy to do so. Just turn the case around here. So once again, we just push that button down to release the other side panel. And let me rotate this around so you can see what I'm doing. Now if you look closely, you'll see we've got the mounting point here and here. I'm going to grab 2 of the screws, 2 of the 4 that came with the optical drive. And I'm going to go ahead and just put those 2 screws in. Let me just warn you, if you're following along with me with the same parts, Pioneer seems to have included a #1 Phillips type screw with their Blu-ray drive. Typically computers use the #2 Phillips, which is a bit wider of a tip, and it'd be really easy to strip these out if you use the #2 Phillips bit. So best to use a #1 Phillips bit, or use the screws that came with the case instead. But just be careful that you use the right bit, or you could easily strip them out, or just have difficulty even getting them tightened trying to use a #2 Phillips bit. Next we can install our solid state drive. So I'm going to go ahead and take this out of the box, and let's see what Intel gives you with your solid state drive. It's a pretty thick box. Let's see, attention, observe precautions for handling electrostatic sensitive devices. The solid state drive isn't really an electrostatic sensitive device, and you can see they've got it in an anti-static bag here, which is completely unnecessary because, as you'll see when I remove it from the bag, if I can get it out of the bag, there are no exposed electronics on it. It's completely sealed. So as long as you avoid touching these gold contacts of the SATA connectors, there's really nothing you can do to harm this as far as electrostatic discharge. You'll see I'm not wearing an anti-static strap, and nothing we've installed so far would matter if you got a static shock on it or not. It's not going to hurt it. So that's just kind of boilerplate corporate speak, just a standard disclaimer. So let me just set that down. This also fell out. This is clay desiccant, throw away. Well, if you say so. All right, there's our empty box. What else do we have in here? There's some other stuff in here. Well, look at this. We've got a giant sticker. Yeah, I'm going to put that on a $350 computer case. Installation instructions, got to have those. Intel data migration software, just set that there. Inside, they've included a SATA data cable, which is nice. They've included some coarse thread mounting screws, some fine thread mounting screws, a Molex to SATA power converter, which we won't need, and a mounting tray adapter, which seems to be in there pretty good. See if I can get that out. Well, that's cool. They put a hole in the back of the box. You can actually just push it out that way. Well, thank you. That was well thought out. Now, this 2.5-inch to 3.5-inch drive adapter is something we don't have to use, but I actually am going to use it because it's going to make the installation removal of the solid state drive a lot easier for any future work. Let me show you what I'm talking about. Now here's a closer look at everything that comes with the solid state drive from Intel. And the SATA cable we aren't going to need because the motherboard comes with 6 of these, and we're only hooking up 4 drives. So we can just put this away. We aren't going to use it. And this power adapter is something we clearly won't need because the power supply we've got will provide plenty of the right power connectors. We won't need to adapt any of them. So these 2 parts can just be put away. Of course, the sticker, you do with that what you want. I'm not putting any stickers on it. Now while we're getting rid of stuff, we can go ahead and get rid of this bag of screws that has the coarse threaded mounting screws. We won't be using those at all, so go ahead and put those away. This bag of screws has the fine threads on it. We'll be using those here shortly. To mount the 2.5-inch drive into the 3.5-inch adapter is very, very simple. The only thing you really need to pay attention to is that this adapter, you'll see, is not the same on both sides. There is a front and a back to it. And if you look, this side here, where these little grooves are, see the distance from the groove to the edge of the plate? And on this side, see the distance from the end of this groove to the plate? This is going to be the back of the drive. So when we mount this in, if we've got it backwards, it won't mount in properly, and you'll have to take the screws out and turn it around. So best to do it right the first time, right? So we're going to grab the solid state drive, and by the back of the drive, I mean where the SATA connectors are. We want to make sure that faces the back of the plate, which is where the grooves are closest to the edge. Now notice on 2.5-inch drives, all 2.5-inch drives, not only have mounting holes on the side, but they've also got mounting holes on the bottom. So if I just turn the drive upside down, like this, and we'll just put the adapter right on top of it, like that. Now that bag of screws had 5 screws in it, We only need 4, so it's nice that Intel throws in an extra one, because you never know. And you'll notice I'm going to use my mechanical driver, and I'm going to start these screws. It's not that my electric driver would really hurt this at all, but it is very expensive, and even though it's not really a delicate device, I just feel a lot better knowing the value of it, that I have full control over exactly how much torque I'm putting on these screws. Now that I've got all 4 started, you can see the drive can move back and forth, and I want the drive pushed this way as much as possible so that our cables can go on a lot easier. So I'm actually going to just hold that with pressure on it in this direction, then just go ahead and tighten these screws down. Now don't over tighten the screws, you just want them to be just a little past snug, and you'll see that's the drive properly mounted into its adapter. Now with the solid state drive mounted in its adapter, installing into the case is very simple. In fact, the toughest part of it is just deciding where you want to put it, because you've got a lot of options. You can put it in any of these 5 bays here, or any of the 6 bays here. So you got to think about your cabling and what that's going to look like. Now initially I thought I would put the mechanical drives right up here in the 2 removable drive bays, but that actually doesn't make any sense, because the removable drive bays are for drives you're going to take out and put in all the time, sort of like having a backup that you would normally use like an external USB drive for. You wouldn't need the added expense of the external enclosure. You could just pop a drive in there and do your backups that way. So I don't want to consume those with his RAID 0 configuration, which once it's installed shouldn't need to be removed or anything unless something's wrong with it or he's going to upgrade it. And they've made the installation and removal of drives so easy anyway. I've decided that I think the mechanical drive should go in front of this fan, where this intake fan is here. So maybe these 2 bottom ports. And for the cabling to look as clean as possible, I think the solid state drive then should go right here, just below where I'm going to put the 2 mechanical drives. And so to show you how easy this is to install, you just push this latch back and this little door swings open and the whole tray slides out. You'll see this tray flexes real easy. And all we have to do is take our solid state drive, and you'll see there are some tabs that stick up here, and the tabs are going to line up with the holes in the mounting tray, and you flex this to get it where you need it to be to get into the other mounting holes on the other side. You'll see the way that this adapter fits in there. It's going to stick out just a bit, and the little SATA connectors are stick out a little bit. Like I say earlier, it's going to make the cables easier to install, since you're not going to have to cram them in the tight spot between the bottom of the adapter and the connector itself. And again, we didn't have to use the adapter. These trays do have the 4 mounting holes if we wanted to screw the solid state drive down in place on the adapter, but this will make it easier to change out in the future. So we've got it, we might as well use it, and we just simply slide that right back into its track. Solid state drive's installed. Now if you thought that was easy, where do you see how easy it is to put our mechanical drives in? Let me just close that back the way it was, because we're done there. Again, decide where you want to put your drives. I've already decided I'm going to use these 2 bottom trays. So I'll take the first tray out, grab my drive, make sure that the SATA connectors are facing the open part of this adapter. And if I can get this on camera, you'll see that there's the 2 steel posts that stick out. Line it up with the mounting holes. And then you just flex this as you need to get the other mounting points recessed into the holes in the drive. Now just be aware that the little metal posts that lock into the drive, they're completely removable, and they may shift around as you mount the drive into the tray. So check it to make sure that they're sitting flush here on both sides. And then it should slide right back in with ease. If there's anything that's, if you're trying to feed it in there and it's just not going in, take it back out and check that. Again, you don't want to force anything. It should really just be that easy. So easy, I want to do it twice. It was just so much fun, I can't get enough. So we're just going to do the exact same thing with the other drive. We'll line up the posts there with the holes on the drive, and then flex the tray so you can get those posts. I can get you a good camera angle on that to line up with the drive. And you'll see how that one just kind of shifted right there. So you want to make sure that gets fully seated, right? It's nice and flush. Check that on both sides. Interesting that you can actually hear it when it clicked into place properly. And again, we just slide that right into its tray, close the door. All our drives are installed. I got to tell you, so far, in spite of this case being very big and intimidating, this has got to be one of the easiest cases so far that I have ever worked on in my 20 plus years of doing this. Next, grab your motherboard box, and the only thing we want to take out of here is our I/O shield. Now, what they've done with this motherboard is they've placed it into its own cardboard tray. On a lot of motherboards, most of them, the instruction manuals and such are on top with the motherboard on bottom. This one, they put the motherboard on top, so we've got to take that out. And then all of our cables and everything that come with the board are located below it. What I want is the I/O shield, which is this metal bracket right here. And then we'll just put the rest of this away for right now, because we're not quite ready for that yet. I'll just take the I/O shield out of the plastic bag it comes in, get rid of the bag. And a little close-up of the I/O shield looks like this. We've got the USB ports up on top. Sometimes there'll be a PS2 port on some motherboards for a keyboard or a mouse. The top of the I/O shield is typically where the keyboard or mouse ports are, but because this one doesn't have that, it's just all USB, I know that the bottom is where the audio ports are. Where you see these 6 holes, this is the bottom of the I/O shield. That's how you know which direction it goes in. If you put it in upside down, it's no big deal to just pop it out and turn it around. It's just held in with friction. Now, to install the I/O shield is very simple on just about any case. Making sure you've got it in the right direction. Just reach in there, and it should just click right into position. Now, that's all I need to do with the case at this point. So what I'm going to do is just get it out of my way. I'm going to go ahead and put the door back on it and then set it aside, because we need to work on the motherboard and get that ready to be installed next. Now, putting our side panel back on is very simple. You'll see we've got some of these little metal tabs that are sticking out on the side here. Not sure if you can get a really good angle on that. In any event, they just go right into these grooves. And it just slips right down into position. And we can close that and get this case out of our way. Now it's time to prep our motherboard to get it ready to be installed in the case. Now, to do this part, we need the CPU, check. We need the RAM, check. And of course, we need the motherboard. So I've already showed you the inside of the box here. Let's open it up again. And you see they've got the motherboard right here on top. I'll lift that up and show you. We can just lift the board, lift the box the board is in. Just take that completely out. And inside the box, you'll see we've got a bridging SLI connector for bridging 2 NVIDIA cards together. Now, here's one I haven't seen before. This is a 3-way SLI bridging connector for hooking 3 NVIDIA cards together. The board also supports Crossfire as well. We've got 2, 4, 6 SATA cables. We've got these really cool quick disconnect adapters for the front port umbilicals and USB. And that's cool because I'm going to show you how to use those later on, and they're really a neat idea. And of course, we've got all of our documentation. What's great is I like to keep all the spare parts or the parts we're not yet using in the motherboard box. And by taking the motherboard out first, all the parts are already remaining in the box. I don't have to move everything around like I typically do when the parts are traditionally sitting on top of the motherboard. I got to take the parts out, take the board out, put the parts back in. In this case, a lot easier. So I'm going to take the board out of its little box here. Of course, it's wrapped in an anti-static bag. Make sure and touch something metal on the case if you're not wearing an anti-static strap. Make sure you're not doing this on carpeting. And when you grab the board, you want to hold it as much as possible by edges and heat sinks, which is what I'm doing to get it out of the bag. And I'm going to just place the motherboard right on the box. And let's get you a better close-up camera angle here of installing the parts onto the board. So here's a top-down view of the motherboard, the CPU, and the memory. And one of the tools a lot of people don't realize you're going to need, more than likely when you're building a computer, is Band-Aids. I just got a cardboard cut on that box. So, you know, you got to be tough when you're building these machines. So I have some Band-Aids standing by. In my experience, when you need Band-Aid, that's good. That means you're close to being done. Although we're only about halfway there at this point. Now there are some stickers on the motherboard that have to be removed. They're just boasting about some of the motherboard's features. If I can hold that where you can see it. That's just trash. Got another one here. Those are just covering up the RAM sockets. You'll see we've got 2 sets of 4 on this board. Now the first component we can install onto the motherboard is our CPU. And installing a Socket 2011 CPU is a little bit different from Socket 1150 or 1155 if you've seen any of my previous builds. This is kind of interesting because traditionally on a Socket 1150 or a Socket 1155 or any of the previous sockets really, you just have this one little load lever and you push it down and away, and then the whole top of this opens up, the retention plate. But they really went heavy duty on a Socket 2011, maybe because of its size, because it's quite a bit bigger. But you've got another load lever on the opposite side, facing the opposite direction. So once you release this one with the hook on it, then you go to the other side and release this one next. See how there's 2 of those? And then you have to push this one back down again, but you don't lock it down, you just push it down, and you'll see that top comes up. We can just go ahead and lift that top up, and that exposes apparently 2011 little tiny pins underneath, which are exceptionally delicate. You know, if you heard me say the 1155s are delicate, imagine 2011, little teeny tiny pins. So keep your fingers away. You don't want to snag any, you know, like your shirt sleeve or anything on there. That'll just trash it. Now I'm going to grab our $1,000 Core i7 3970X CPU and let's take it out of the box. Oh, I don't know, $1,000. It's pretty pricey. Better be careful. A little nervous. Actually, I'm not. I do this stuff all the time. All the chips install the same, whether it's a $100 chip or a $1,000 chip or a $10,000 chip. They're all pretty much the same. So let's go ahead and see what we get with our $1,000 processor here, shall we? Let's open that up. That box is empty. We've got a Go Faster sticker. See, if you put that sticker on your computer, it'll go faster. Pretty much the same little instruction booklet that Intel includes that I've never ever read, and I can't imagine what could possibly be in there that would be of any value to anybody. Maybe an engineer. Let's open that up, and that exposes the CPU, which is in a plastic case, just like all the other CPUs. You can see it's quite a bit larger. That's almost 2 inches square, which is almost twice the size of a regular, when I say regular, but of the Haswell chip, let's say. So you get your finger underneath one of those tabs there and just lift that straight up. And then you'll see there's 2 indentations in the plastic here, which we can get our fingers on and get that out. And once again, you want to avoid touching the top or the bottom of the CPU. You'll see me handle it by the edges, and you see me handle it. It appears to be a delicate way. There's nothing delicate about the CPU. The CPU is a solid state component. It can be dropped and kicked and it's going to be fine. We're not going to drop and kick a $1,000 CPU, but it would be fine if we did. I'm not recommending that you do it. The reason I'm holding it like this is because I want to keep my fingers off of the heat spreader on top, and I want to keep my fingers off of the contacts on the bottom, the little landings there. Now to orient the CPU in the right direction is very simple on a Socket 2011. You'll see in the corner here, there's a gold arrow. And on this corner, right down here on the socket plate, there is also an arrow. So those 2 arrows are going to go together like this. Also, just to make sure you don't screw it up, there are little notches here on the CPU, and they're a different distance away from the edge. So if you tried to put the CPU in this way, these little notches won't line up with the tabs. And so you really don't want to experiment with that because, as I mentioned, these are very delicate. So what I'm going to do is just put one end in here first. And what I'm doing here is just lining up the little tabs with the holes. Then I'm just going to gently set it down, and it should just seat right into position. And I can grab the edge here and just make sure it doesn't really shift left or right, and it's looking pretty good. So we can go ahead and lower the retention cap down and raise this load lever up. And now we can bring, this is a little confusing. I can push down on the lid here and then bring the other load lever down and lock it into position. And it is springy, as you can tell. And I'm doing it away from me. When you're doing this, you probably want to turn your motherboard as you need to so that the load lever is facing you as this one is facing me. And then we'll just put that load lever back down, and that plastic top should pop off. It didn't, but we gave it a little boost. And you want to make sure you keep this, they call it a PNP cover. This protects those little pins anytime there's a CPU removed from the socket. So if you ever take the CPU out and you're going to leave the CPU out for any period of time, put the cover back on it. The manufacturer will not honor the warranty if the board is sent in for warranty work without that cover in place. Next, we can install our memory, and for the best performance, we're going to install the memory in dual channel in each of these memory banks. Now, how do you know which of these sockets to use? Well, you're going to refer to your motherboard manual depending on how much memory you've got. We've got 4 sticks, 8 gigs apiece, and the manual specifies to use sockets A1, B1, C1, and D1, or as they're laid out on the board, A1, B1, D1, and C1. And you'll see written on the board in very fine lettering, it says DIMM A1, DIMM A2, DIMM B1, DIMM B2, and then over here for this bank, listed in the order that they're in, it says DIMM D2, DIMM D1, DIMM C2, DIMM C1. Basically, to make matters simple, we're going to use the blue sockets. Now, the memory on this board installs a little differently if you've seen how I've installed memory on other boards. Even though it's the same memory, these little retention tabs that pop over to the side, normally you have those on both sides, and on this board, these on the other side don't move. So I just need the blue ones open. And we're going to get our memory here, another $350 worth of memory. Get that open. All right, let's get this opened up. Now you can pick up the memory anywhere on the heat spreader. Just want to avoid touching the circuit board. Yeah, let's get that out of there. There's one. You'll see there's a notch in one side, there's a notch in the memory, and I'm going to start with the one furthest from me, and we'll just plug that in, push down one corner, then the other corner. And there's 8 gigs of memory installed. And we're going to repeat this for the next one. Again, orient that in the right direction. Set it in its socket straight up, and then one corner, then the other corner. There's 16 gigs of memory. This memory weighs a lot. All right, let's see. We're going to go to this next socket, which actually, if you notice, the RAM is turned opposite of this RAM. So that's why you got to pay attention to where that groove is, that it lines up with that socket. Actually, I'm going to start with the one closest to me here so that you guys can see it a little better. So I'll put that one in its track. Don't try and push it down until it's seated in its track properly. Then one corner, other corner. And finally, do the exact same thing here in the other blue socket, the last remaining blue socket. So we've got 8, 16, 24, 32 gigs of memory installed. Now, Because we're using the H100i water cooler, we can't put that in until after the motherboard's mounted in the case. So at this point, our motherboard is prepped and ready to be installed in the case. Now, to install our motherboard is going to be easier if the case is laying flat down. It doesn't have to, but to work with gravity is just a lot easier. So because the case is so big, what I want to do is clear this counter off, because anything that's on this counter may get knocked over while I'm trying to get this case ready. Because what I've got to do now is take off both doors and lay the case flat. So let me get the motherboard safely out of the danger zone here. Danger zone! All right. And turn this around so you can see what I'm doing. And it's the same process. We're just going to push down this lever, swing the door open. We can grab the handles on top and pop the door right off. And we're going to set that down very gently. And I'm going to do the same thing with the other side. Next, I can rotate this around. It's a little lighter now, actually. And let's go ahead and turn it all the way around. This is our motherboard tray here. The motherboard tray, unfortunately, is not removable, which would make this job a little easier. If I had one complaint with this case so far, it would be that it doesn't have a removable motherboard tray, because the overall size of this case does make it a bit more physical to get it into the position to get the motherboard ready for mounting. So let me just go ahead and turn this around so you can see the front of it here. We're going to lay it down in this direction. I'm going to close these hinges because I don't want to scratch my countertop. And very gently, just going to lay the case down. Now, laying this case down, as you can see, it doesn't lay flat. It's got a wobble to it, but it's still going to make installing the motherboard easier. Now, the first step in installing our board is to just get this cabling out of the way, and it doesn't really matter what you do with it. You can remove the twist tie. In fact, I think that's what I'm going to do, is undo this twist tie, and it's a wire tie, which has got metal in it, and we don't want this in the case anyway, because it could eventually break free and short something out. And we got another one right here. Let's go ahead and get these off of here. And we can take this big bunch of cables and just drape it over the side. Don't worry about where they go or what they do at this point. We're just gonna get them out of our way. We don't want to trap any cables underneath the motherboard when we're installing it. Get rid of those. And you can see we got a little bit of a strange tangle here. There it is. Okay. Let's get all that out of the way. It's like a surgeon. And then we get this fan power connector out of the way. We got another fan power connector that looks like it's going to get in the way, so we'll remove that wire tie as well. And drape that over that side. Now, what we've got to figure out is where the motherboard standoffs go, and this is where you want to be really careful. You only want to put a motherboard standoff where there's a matching hole in the board. If the motherboard standoff hits the back of the motherboard when you apply power to it, you can toast your motherboard, and that would not be good, especially when you've got as much money invested in your system as this person does. So I'm going to grab our motherboard here, got it off to the side, and you see I pick it up by this heat sink and the edge just to lift it up, and it's got a lot more weight to it now that the memory's on it, so I don't want to hold it like that very long. I just want to get it up in the air and get it so I can properly hold it. And you can see it's got to be oriented in the right direction. We want to face the keyboard hole, or in this case our USB ports, which are right up here, are going to be up towards the top, which is closest to me. And this is a difficult board to hold properly because it doesn't really have any any handholds on it. So you want to make sure you're well grounded here, and we just want to set the board down into place. It's what I call a dry fit. And there's already one motherboard standoff under there. So I don't know why they just put one in there, but they did. And I just want to line these I/O ports up with the I/O shield. Ooh, that fits nice and snug. Now I can see the motherboard standoff that was there comes through this hole on the board. And what I want to do, oh, there's another one right there, so there's 2 in place already. I want to count how many total mounting holes this motherboard has. And then I'm going to count off how many motherboard standoffs I have, or put in the exact same amount. So we've got 1, 2, 3 on the bottom, 1, 2, 3 in the middle, and 1, 2, 3 on the top, for a total of 9. And I just kind of take a good look at where these screws have to go. These are all in a straight line, these are all in a straight line, and these 2 are in a straight line, and the one on top is just a little to my left, your right. So try and memorize that. Go ahead and take the board out. Now in the bag of screws that came with this case, there are some brass, well, they may not, I think they're brass, motherboard standoffs here. Those are the gold color ones. Now I've just pulled 7 standoffs out of this bag. There's still quite a few extras in there. Set that aside for right now. Also in this bag, they include a little 5mm socket with a Phillips head on the end. So that way you don't have to buy any special tools. That just fits over this motherboard standoff, and then you just use a regular Phillips head screwdriver to tighten it down. That's a really nice touch. I'm not going to use this because I actually have a tool which is very inexpensive. It's just a 5mm socket, and I've got a ratcheting driver. And we just have to remember where these go. I know that these 3 on our line, there's really only 3 holes that we can use in this particular line. And I just want to tighten those down by hand at first. That one's a little tough going in, so I guess I'm going to have to use this to tighten that up. All right, so there's 2 in place. And then I believe we were at the far end here. Now these I don't want to tighten down because I'm not exactly sure if it was this row here or this row here. So I'm just going to go ahead and set these, just start these out just a little bit here. Put those 3 in. And then these last 2, one goes here where it's labeled, well, basically A, B, C, and this one's going to go here. So basically we're using the available holes on the top around this CPU tray cutout. I can tighten these down because I know these are in the right place. Now if we look closely, these are actually labeled A, B, C, E, F, G. I guess we're not using D, wherever that is. And down at this end we've got R, S, and T. So I'm just not sure. I'm going to find out now if I put that down too far. It may have to go one over, but this is a pretty big board. So I think that's the right place. I'm going to just make those flush. All right, now to see if I got it right. So we'll grab the board again. And once again, very gently set it down. And do take note of how I'm holding the board and try and mimic that when you do yours. Really want to hold it by the edges, hold the heat sinks. Try to avoid touching the circuit board or the bottom of the board. Okay, so the far standoffs I put too far away. They need to come up 1 row, but the top 6 I've got correct. So this is why we check it. We'll take that right back out. So we're going to use the holes in the back of the case here that say L, M, and N. And the RST ones are just too far away. Those are the next set down. Now remember, we had 9 mounting holes in the motherboard. Count your standoffs. You don't want to have 10 standoffs. You're going to be in trouble. You know, one's going to ground against the back of the board. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the perfect number. And we should be able to see them through all 9 mounting holes on the board when I install the board again. This should be for the final time. Line it up very gently with the I/O shield. And I can see all 9 standoffs through the holes in the board. Now pulling out this bag of screws again, I've pulled out 9 of the fine threaded hex head screws. There's also a fine threaded flathead screw that's fits flush. Those are for use with the 2.5-inch hard drives. They're a little more shallow. They're not quite as long as these screws, and they may not have enough length on them to get the motherboard to reach through to the standoff. So these are the actual screws you're supposed to use with the hex head and the fine thread. The hex head with the coarse thread, those are also in the bag, and those are the traditional screws that are used for other hardware items. So you don't want to use those, and in fact you can't. They won't thread properly, so you wouldn't go too far if you tried. I'm going to use my mechanical screwdriver on this, and we're going to get all 9 of these screws started. Now, of course, the reason I don't recommend tightening all the screws down as you install them is so that you can shift the board left or right or up or down as you need to line up the other holes. However, this case is such a perfect fit that once the motherboard was lined up on the 2 standoffs that were already installed in the case, it actually kind of sits down over them and locks it right into position. So we can go ahead and tighten these down now, but nothing wrong with being a little extra cautious anyway. And I just want to take these just a little past snug. We don't want to over tighten. Now here's what it looks like with the motherboard installed and standing upright again. And next we can install the H100i liquid cooler. Now installing our water cooler, or any water cooler, into this case should in theory be very, very simple. Let me turn the case around and I will show you that there is this one thumb screw right up here. So let me get my screwdriver out and take this single thumb screw out. And then this whole top should just come right off. And it does, like so. And then for this next shot, I need to actually lay the case down so you guys can see what I'm doing. I don't want to crush my cables, so we'll just get our cables lifted up and out of the way here. And I want to bring the case straight down and slide it back a little bit here so you can see. Well, who am I kidding? So I can see. Because what I need to do is I need to take this fan out. You'll see the radiator could actually fit over on this side too, but for best airflow I want to put the radiator using these 2 fan areas here. So we're going to remove the fan that it comes with, and there's just 4 standard fan screws that hold that fan in place. And we're going to replace this fan with the matching fans that come with the liquid cooler. Now when I take this last screw out, that fan's going to want to fall out. So you want to hold the fan in place. And again, it's good to have a magnetic tip screwdriver. As I said that as the screw just fell off. The magnetism's getting weak there. And I'll just set that fan down. And if I lift the case up a little bit here, I can take that fan out and we can put this fan away. It can be reused in other places on the case if the owner chooses to do that. I'm going to choose to leave it out because it's really going to be overkill anyway. Now let me show you what you get in the box with the Corsair H100i. Just open the box this way, and on top you see we've got our documentation, and there's some other products and warranty information. Set that aside. And underneath here we have lots of plastic. We've got our 2 fans, 1 and 2. We've got our cables for hooking up power and everything up to the fans and the water cooler itself. We've got our brackets right here. And got a bunch of screws that we're going to need. And then we can take the radiator out. And the radiator has little fins on it, just like a car radiator, that are easily bent. So don't squeeze it too hard. And it's permanently attached as a closed loop system to the water block. I'll go ahead and remove the plastic from around it here. And let's get that box out of the shop, because that box is, yeah, it's completely empty. I don't think is there anything underneath? Nope, nothing underneath. It's completely empty. It's out of here. All right, so there's our radiator with the water block. You'll see the water block has a plastic cover over the end, and it's got thermal compound already on it. That's why that plastic is there. It's to keep any contaminants, your fingers, finger oils, off of that thermal compound material, because that will impede its efficiency in heat transfer. So you leave that on until you're ready to apply it to the CPU. Now here you see you've got a couple of brackets, and this bracket right here actually just goes right over the top of the water block. That's actually what's going to hold it in position. Now a couple of these parts we won't be using. For example, this is an LGA 1150, 1155 backplate. This is used for AMD chips, so we're not using either of these, so they can be gotten out of our work area here. Fans I can set aside. We're definitely going to need these fans, so we'll just set them aside for now. All the screws and everything that we need, there's actually more than what we need in here. We'll get to that in a minute. And then the cabling, we won't need that for a little bit, so we'll set that aside. Now in this bag of screws, if I open this up, we're going to look for the LG 2011 standoffs. Now these standoffs over here on the left, these are for LGA 1150, 1155 Intel CPUs, which we won't use on this build. These four standoffs, you'll see one end is shorter than the other. These are used for the LGA 2011 Intel chip, which already has a backplate installed. And we're going to start with these four standoffs. Now using the short end of the standoff, you'll see that there's already holes right in the corners of the CPU backplate. And we can just put these in by hand. Now there's not really any special tool to use to tighten these down. You want to get them as tight as you can with your fingers, but when we put the thumb screws on them, the thumb screws will tighten them down automatically for us. Now my initial thought on installing this radiator was to put it up on top and to bring the water block down, and then they have the fans below it pushing air through. However, and unfortunately, I really thought the Cosmos 2 case was going to give us more options, and it locks us into having to basically turn the radiator around the other way and to install it from the inside. What ends up happening when I try to install it on the outside of the case is it hits, there's a bracket, support bracket here for these carrying handles, and it hits that. Basically, the radiator needs to come over a little bit more towards me in order for the holes to line up with the screws below. But it's not that big of a deal. What we'll end up doing then is installing the radiator in this direction inside of the case with the fans on top. The fans will still be pushing air out of the case, but they'll be pulling it through rather than pushing it through. How that affects the performance of the water cooler is probably negligible. Corsair does recommend when you have a choice between push and pull to do the push. However, with this case design, we have to put it in a pull design. Now we could add 2 more fans and have a push and pull configuration, but that would be way overkill and unnecessary. So what I'm going to have to do to get this radiator installed is actually turn this case around, and then I need to bring it down this way. And that way it's going to be able to hold the radiator, or make it easier to hold the radiator, and I'll be able to film it at the same time, and of course have access to the screws to be able to see what I'm doing. So I'm going to start by grabbing the radiator here and aligning it to the approximation of where I want it to be. And just watch that water block on the motherboard, send it very gently down there. We're just going to visualize here where the holes are going to line up. We want the 2 holes in the radiator to line up with these 2 center holes. Okay, so we'll set that down. Now when you go to install your fans, you might say, well, how do I know which way the air is blowing on the fans? Well, if you look very closely on somewhere around the shroud of the fan, there's typically 2 arrows. One that shows the direction the fan is going to spin, which in this case is towards me, and another indicator showing which way the airflow is going. So in this case, out this way. Another way you can tell, without looking for these little indicators, and not all fans have the indicators, is you see the Corsair logo and how it moves with the fan on this side? And you see the Corsair logo on this side when the fan moves, that logo doesn't turn. that's the way the air flows. So if you look for the center that doesn't turn, that's the direction the air is going to come out on every fan I've ever seen, regardless of who makes it. Never hurts to double check and check for the arrow indicators just to be certain, but that's just a little tip from your Uncle Kerry. In the bag of screws that come with the H100i, there are 8 really long screws, and we need all 8 of those for this next step. You know, this is where it helps to have 4 hands, as you can see. Now the fan, of course, the non-moving part, that's the direction the air is going to go, so we want that to be facing us. And this is the hole that we're going to use for the power cable for the fan, so we want to turn the fan so that that can easily reach there. And we'll grab one of the screws. And we just want to get these screws started by hand once we have the proper alignment for the radiator. Now I'm going to grab my mechanical screwdriver and just bring these not quite to snug, but I just want to make that radiator a little tighter so it doesn't move around when I install the next fan. So the same thing, we're going to run the power cable right through here so we can visualize where we want that to be here, set it up. And again, we're going to start these screws by hand as well. Once you've got all the screws started, go ahead and tighten them down. You don't want them too tight. If they're too loose, you might hear it vibrate. And if they're too tight, you can strip the threads right out of the radiator. And you certainly don't want to do that. And tightening in opposite corners will help when you're doing this, because as you tighten one screw down, it may actually make the screw in the opposite corner loose. So once you think you've got them just the way you want them, you need to go back around and make sure that they're all about the same tightness. I can't stress enough, do not over tighten these screws. You can crack this plastic, you can strip the threads out of the radiator, as I already mentioned. You just want to take them a little bit past snug, and you want to make sure that all 4 corners are equally tightened. They don't have to be exactly the same. You don't have to use like my electric screwdriver has a clutch setting. You wouldn't have to use that. In fact, the electric screwdriver could easily strip those out, and that's one of the reasons I'm doing it by hand. And we can take these power cables and feed them through this hole right here. Take both of them and feed them through. Now while I've got the case down in this position, you can better see how this lid goes back on. You actually put it on almost all the way here, and it's got a couple little tabs that stick up right here, and they just go right underneath. You can actually kind of feel it lock into position. And then we have our thumb screw. And that's what it looks like with the cover back on it. I can go ahead and bring this back up onto its feet and turn it around here so you can see. And again, you want to be real gentle because that water block's just hanging there and it'll bang up against that board and could cause damage. Also, watch your loose cables here. We don't want to crush them. Turn that a bit there. And now you can see we've got our radiator installed up here with the fans on top. Next, we can install the water block onto the CPU, but I do want to show you on the water block that there are a couple of power connectors here on the side, and once I mount the water block to the CPU, I won't be able to film those to show you. But we're going to be using one of these here after we've done this. And then on the side, there's another power connector and a USB port, and the USB cable we're going to hook up a little later, and that is what controls the water block and monitors it. So now we can remove this plastic cover that's been protecting our thermal compound, and I can rotate this the way I want it to look, which will be, let's get the cable out of the way, which will be just like that. It's going to fit over the standoffs we installed just a moment ago. Set that right on there, and we're going to grab the thumb screws, and we'll just put those on by hand at first. Next, I want to take a mechanical screwdriver. Don't use a cordless screwdriver. It's very easy to snap these off. And we want to tighten opposite corners. At first, just bring them till they're a little tight to turn. And do that to all four corners first. And then you want to tighten them down well past snug, but don't muscle it too hard. Like I said, you can break the standoff inside of the thumb screw. But we want a nice firm surface or firm grip between the surfaces of the bottom of the water block and the top of the CPU for the best thermal transfer. Now here we've got a power cable that's coming out. This is a SATA power cable, and that's going to power the water block itself. And this is this would go where the CPU fan header is on the motherboard. Located on the top right of this motherboard, you'll see there are two CPU fan headers, and they're labeled right on the board, although I'm sure it says it in the owner's manual as well. But it says CPU fan and it says CPU optional. So the CPU fan is the one on the left and the CPU optional the one on the right. So we're going to grab the fan header off of the water block, which is a 3-pin plug, and we're going to plug it onto the main CPU fan connector, which is a 4-pin connector, but it's got little grooves on it, and it'll line up with the notch that sticks out and go right over the proper 3 pins you're supposed to use. Basically, the pin on the far left isn't going to be used, and the entire connector to the right, the optional fan connector, we won't be using that at all either. The H100i comes with 2 fan connectors and a USB cable. Now these fan connectors are the same. It doesn't matter which one you use. We're only going to use one of them because each one controls 2 fans. As you can see, there's a little Y adapter here to control 2 fans. You can have up to 4 fans on the radiator, 2 on the bottom and 2 on the top in what they call a push-pull configuration. But since we're only using 2 fans, we only need one of these cables. The other one can be put away. So we're going to start by hooking up the radiator fans to the water block using this power connector. You'll see one end of it has 2 standard fan connectors on one end, and the other end has this kind of funky connector on it that's got a clip on it. And up on the top of the water block, there are 2 ports that you can use either one for powering your fans. And with the clip facing towards you, select one or the other. I suppose whatever the cabling is going to look best is going to be, the deciding factor if you use the right or the left side. And then it's kind of hard to see, but there's a little groove in there. And don't force it. It should, when you get it lined up properly, should fit right in. So I can feel it's gone into the groove there. And if I just push it straight down, it clicks right into position. Then we're going to grab our fan power cables coming down from the top above the radiator and plug each one in. It's a 4-pin connector, as you can see here. There's a groove on one side so you know which direction it goes on. It doesn't matter which fan goes on which connector. And we'll hook both of those up. The next cable we can hook up is the USB cable. We're going to use this end first, and this end plugs into the water block. There's a connector right here on the side that I showed earlier. And just rotate the cable so that the cable faces up. The connector is going to go on this way. And let's see if I can get you a good angle on that. It just plugs in like so. And in a perfect situation, you would be able to take the other end of this cable and run it up through the top corner of the motherboard, way up here. Pull that through. Now, unfortunately, the Cosmos 2 case doesn't have any holes in the motherboard tray down here at the bottom to pull this cable back out. We have to bring it over to the side over here and then back over again. That's going to make the cable pretty taut. It will reach just barely, but clearly the designers of the Cosmos 2 definitely did not have the H100i in mind when they were designing it for water cooling solution. However, you'll see I've got about this much cable left. without pulling on it too tightly. And the USB cable, just like in other videos I've shown, it's a standard USB 2 header. We've got 3 blue ports down here that we can plug into any of those 3. And 1 pin is missing. That's how you know what direction this goes on, so rotate it in the proper direction. I'm going to put it on the one closest to the end so I'm not pulling that cable too tightly. And then we can kind of clean that cable up just a little bit, maybe just get it off of the heatsink and push it down a little bit. And then the last cable we'll have to hook up is the power through the SATA, which I'll show you how to do here in just a little bit. But for now, that completes the water block install. Now with the water cooler installation finished, the next thing we can hook up are the data cables for all of our drives. However, the owner of this computer has been watching these videos as I've been posting them and seeing as his computer is progressing along. And he and I spoke, and he had a really good idea that I couldn't agree more with. And that is, he's actually not going to use these bays down here on the bottom. And he's thinking he'd like to reduce the weight of the machine, and instead of having the solid state drive down here where I've placed it, just put all the drives all together up here. So I think that's a great idea. In fact, what we can do is simply slide this tray out from up here. And let's take this tray from down here and we can just move that up one, right? And again, I don't have to move these drives. I just think it'll be more logical that way. And then we'll take the SSD drive out and move it just like that, and put the empty tray right back in here. So now I've got the solid state drive on the bottom and the 2 hard drives just above it, and we're just using this area here, and that means all this can come out, which is going to reduce weight. I think his thought was he was going to improve airflow, but because these are all compartmentalized, I don't know that that's actually going to do anything for airflow. However, this whole fan mechanism just comes straight out. You just pull it just like that, and you can see that pops out very easily. And then these 2 drive cages also come out real easy. If I turn the case around, now if you look closely on the other side, you'll see there are 2 thumb screws right down here that hold in each of these cages. So 2 thumb screws here, 2 thumb screws here, and we just need to remove both of these thumb screws. And you may require a screwdriver to do this. They were in there pretty tight. I just went ahead and loosened them up off camera so I could use my hands to show you how those come out, since they're called thumb screws, so you can take them out with your finger and your thumb. But like I said, from the factory, they're actually pretty tight, and they should be. They hold the cages in place. Let's turn this thing back around. And now, I have that on camera, there we go. We can grab this top lip here and pull the cage straight out. There's 1. And pull the other cage straight out. There's 2. Now with those cages removed, you can see we've got this big open area down here, and as far as improving airflow goes, as you can see, there's really no place for the air to go that's going to be beneficial to the rest of the computer. The only thing down here is the power supply, and it's bringing air in from the bottom and out the back. And this is all sealed off. There's a couple of wire grommets down here, but for the most part, this is a sealed compartment. And this is a sealed compartment, so this really doesn't improve airflow. However, I was really eager to do it because it takes a couple pounds off the system. It's going to make it a little lighter. So I'm all for that. Now's a good time to familiarize yourself with the SATA ports on your particular motherboard. This isn't something you can really do by just looking at them. I had to refer to the manual, and the manual explains to us that this top white port up here is a SATA 6 gig per second port. These 2 blue ones are SATA 3 gig per second ports. And this other white one on the bottom is a SATA 6 gig per second port. However, why it's separated is because these 3 pairs of ports are all based on the Intel chip, the Intel hard drive controller. And this bottom one is based on a Marvel hard drive controller. There's a limitation on the earlier chipsets that limited you to 1 pair of Intel 6 gig per second ports. That doesn't exist on the modern Haswell chips today. However, that's why they had to do it this way. What's the difference between them? Well, the bottom port here, this Marvel, has a feature called SSD caching, which we're not going to use. But what solid state drive caching was is when solid state drives first came out, They were really small in capacity and very expensive to purchase. And the idea was you could buy a cheap solid-state drive, relatively cheap one, and use it to cache your mechanical drive to boost your system performance. Today, solid-state drives are much more affordable and have much larger capacities. So the solid-state drive caching, by the time it was created and introduced, was pretty much obsolete, unfortunately. It was a good idea, but the technology, the hardware technology, surpassed the software technology in this particular case. So by knowing the speed of the ports, and knowing which one's the Intel port and which one's the Marvel port, we can then determine where we're going to plug our devices. For example, we're not going to plug our optical drive into a SATA 6 gig port. In fact, on the Marvel controller down here, you can only plug data drives into it. An optical drive won't work, and if it did work, you'd be wasting it, because an optical drive can't transfer data at that speed that this port can offer. So by planning this ahead now and knowing where we're going to plug our cables in, it all makes sense, because pretty much what it translates to is that our RAID array, our RAID 0 array, is going to go down here on the Marvel controller. So both of those Seagate Constellation 2 terabyte drives are going to plug down here and use this pair and consume that Marvel controller. On the two blue controllers, we're going to use all four of these. Think about it. We've got the optical drive, we've got the two external removable trays, and we've got an eSATA port that's on this front I/O of this motherboard. So that's four devices, right? The optical drive, the two externals, and the eSATA connector. That's going to consume all four of those. That just leaves our solid state drive, which we'll plug in onto the Intel 6 gig per second port. Now, why not plug the solid state drive into the Marvel and use the Intel 6 gig for the RAID? Well, I tried that, and Windows 7 would not install without a driver. It couldn't recognize any of the hard drive controllers, and by simply reversing that, Windows 7 installed without any hesitation at all. It found everything just fine. So learn that one the hard way. Sometimes you have to experiment with this stuff, which is what I had to do, and was able to determine that solid state, if the solid state drive is plugged into the Intel 6 gigabit connector, we can configure the RAID on the Marvel controller and everything's great. Everything runs fine. So that's where our SATA cables are going to go, and let me show you them as we hook them up one by one. In fact, now that I think about it, with the solid state drive going on the top SATA controller, I think I want the solid state drive to be the top drive. It doesn't have to be that way, but I think the cabling is going to be cleaner to come in from the top and go into the top. So again, this isn't going to affect how the system works. It's just a matter of keeping the cabling clean. So all I'm going to do is remove the solid state drive from the bottom here and remove these, this one Seagate Constellation 2 terabyte drive and move it to the bottom, and then go ahead and put the solid state drive right up there. Now you've seen me move these drives around 3 times. Because I haven't built with this case before and I'm kind of figuring it out as I go, the only other alternative would be to completely build the system off camera, figure out where everything needs to go, take it all back apart again, or have a duplicate system and then recreate the work. So this is the fun part of filming, where I get to do things 2 or 3 times, but it's just because of my lack of familiarity with the case, and of course knowing the limitations of that Marvel controller, having the main drive hooked up to that for Windows 7 to not recognize it. And I'm sure there's a way to do it with installing drivers and everything, but just to make life simple, we're going to go ahead and make sure solid state drive, once again, going to go up on the top Intel based controller, and the RAID 0, the 2 mechanical drives, which are now down here on the bottom, will go on that bottom Marvel controller. Now in the motherboard box, I've pulled out the SATA data cables. You'll see I've got 3 pairs here. That's 6 cables total. There's 2 in each bag. And they're not all the same. These have little white caps on them, or actually white connectors. They're not caps. And these are solid black. And according to the manual, the solid black ones are for SATA 3 devices, like your optical drive. And the connectors that have white on them are for SATA 6. Now I haven't actually done any speed testing between the cables to see if there's really a difference, but I guess there must be for Asus to go through that trouble. So let me show you how you hook these up. Now when I hook up my drive cables, the way I decide which one I want to start with is by figuring out if I use this end of the cable and I start at the top, it's going to drape down and it could interfere with my access to the lower drives. So I'm going to start with the lower drives, and that way there's no interference from the cable as I connect the drives above. So we'll start with the bottom drive, again using the L-shaped connector of the SATA 6 cable, and that's just going to plug straight on, just like that. We'll take the other end of this cable and we're going to run it right through this wire grommet right here. Then we're going to take the other end of this cable, and remember that's coming from the drive that's located on the bottom, and we're going to plug it in to the bottom connector. This is not a technical reason why we're doing this. This is a logical reason why we're doing this, which will make working and diagnosing on the system later much easier. Bottom drive, bottom connector. Take the next SATA 6 cable. We're going to do the exact same thing on the next drive up. And again, right back through that wire grommet with the other end. Now we take the opposite end of that cable and go ahead and plug it right above the cable we just plugged in. So that consumes that Marvel controller, the 6 gig per second controller. And then we'll take the last SATA 6 cable we're going to use, again with the L-shaped end, plug it into the solid state drive. And this one, the connector's a little bit higher up, so to keep the cable as clean as possible, we'll go to the wire grommet up above and feed that one in. Now I'm going to take the other end of that cable, and on this connector up here, the top one that we're going to plug into next, it says that port 1 is actually on the top and port 2 is on the bottom. So I want to plug it into port 1, which is on the top. It'll actually work in either one, and it may be a little easier access in the future if you plug it in the bottom one, so that if you want to add another drive, that port will remain open. However, I like to use the port numbers in the order of priority of booting, although that's technically not a limitation. You can work around that. That's just my OCD for you. Now remember, as I pointed out earlier, we have our 2 removable hard drive trays here that we have to hook up. So if I just rotate the case around here, we're going to dig through all of these cables. And again, don't let these cables intimidate you. What we're looking for right now are the 2 SATA data cables that are coming off the back of each of the trays. There's one on the top tray, one on the lower tray. You might want to just route those around right now. Make sure they're not tangled up with it. See how I got this group of cables completely out of the way. So I'm going to take the bottom drive tray SATA connector and place it on the bottom connector here. And the SATA cable from the top removable drive tray, I will plug in just above that. Now way up here at the very top of the computer where all of our I/O ports are, this connector right down here is an eSATA connector. I don't know if the customer's going to use this or not, but we might as well hook it up. We've got the ports. So once again, I'm going to turn the computer around to the side, and looking through this big bundle of cables, I want to find, there should be a SATA cable here. It's going to look unlike any of the other cables. Here it is right here. Again, a good opportunity to make sure it's not tangled up with any of the other cables. Now this SATA cable, I'm going to plug into the bottom port of this final blue connector that's labeled port number 4, which is on the very bottom here. Plug that straight on. Next, we'll take one of the SATA 3 connectors, which is all black, and again, using the L-shaped end of it towards the optical drive, we'll plug that right in. And the opposite end of this cable, we're going to plug into the last SATA 3 connector right there, and that hooks up all the data cables to all of our drives. Now you might ask yourself, why hasn't he plugged the video card in yet? Well, if you look closely at the system, the video card's going to be about this long, and it's going to cover up these ports and make them very hard to access. It's also going to block our view of connecting in our front port switches. So it's best to save the video card for later, and that's exactly why. It's not that you can't do it, but it does make your assembly process harder than it needs to be when you plug in parts in an inefficient order. Now, speaking of that, one of the things that's going to be much easier to hook up now without the video card in our way is this rear case fan. Now, one of the reasons this case has so many wires coming out of it is it's got this built-in fan controller. And the fan controller is really designed to control the front fans and side fans and top fans. There really isn't an option for the rear fan. I guess they intend for that rear fan to either run at one speed all the time or to be plugged directly into the motherboard and let the motherboard control the speed. So for that reason, they've given us an adapter that allows us to plug the fan directly in the power supply. And if we do that, it's going to run one speed all the time. We're not going to use that. We just unplug the adapter, and that reveals a 3-pin fan header. Now, this adapter we won't use. That can go in the motherboard box with the rest of our spare parts we won't be using. And on the motherboard, right there is our fan header right there. It's labeled CHA fan or chassis fan. Now, that's a 4-pin fan header, but this is only a 3-pin fan plug. That's okay. You can plug a 3-pin fan into a 4-pin fan header, no problem. It's got little grooves on it so you know which of the 3 pins to use. It just plugs, in this case, on the first 3 pins starting from the top, and the bottom pin is the one that's not used. It's just that simple to hook up. Now, the next connector we can hook up is our front port USB 3.0. It's a very different looking connector. When you look in this big bundle of intimidating wires, you'll see there's one that's just completely different from all the others. It's this kind of thick cable. It's got 2 cables going into a 19-pin. It's actually got 20 holes. They call it a 19-pin. Sometimes they call it a 20-pin connector. And there's a spot here on the motherboard. Typically it's blue, which signifies USB 3. And it's got both the connector and the plug have a notch in it, so it only goes in one way. And just rotate that in the right direction and plug it straight on. Now, speaking of USB, we might as well go ahead and hook up the 4 USB ports that are up here on the front I/O as well. They also look different than all the other cables here. With this case, they're actually rounded cables, as they are in most cases actually, and it takes one connector for each pair of USB 2s. Most cases only have one pair of USB 2s. This one's got 2 pairs of USB 2s, which means it's going to have 2 cables. And those cables are going to look exactly identical. So looking through this big bundle of wires, I'm looking for the rounded cables here going to a regular square termination block, which is what I've got here. And there's 2 sets of them. They're exactly identical. They're twins. And what I've done is I've actually separated them from this big bundle of wires and ran them separately, untangling them along the way to the bottom wire grommet here. Since we're going to run them along the bottom, if I can just arrange that right, see, we'll untangle that, run it right along the bottom, and they're going to go right here onto these 2 remaining USB 2 headers on the motherboard. It doesn't matter which connector you plug where. There is a pin missing on the connector and there is a pin missing on the plug, ensuring you can only plug it in one way. So we'll go ahead and just plug one in here, and we'll plug the other one in right there. And that consumes all of the USB 2 ports between the 2 front pairs of USB 2 and then of course our H100i water cooler. So with this motherboard, they gave us exactly the amount that we needed. Now, in this giant bundle of cables, there should be one more rounded cable. And again, I'm talking specifically about the Cosmos 2 case, and these rules apply to most cases, but if you have a different case, it's possible yours will be a little different. But this is the last rounded cable. All these other cables are flat cables. And this is our front port audio connector to allow us to plug in headphones or a microphone on the front port I/O up there on the top of the case. Now, you'll see it actually breaks off into 2 separate connectors. One says HD audio and one says AC97. Motherboards haven't used the AC97 in a long, long time. I'm surprised that they included this in the Cosmos 2 case. I guess they were being thorough, but we won't be using that one. You use one connector or the other, not both. And if you're building a modern computer, you're going to be using the HD audio connector. They're both wired up exactly the same as far as the connectors go, because it's going to fit on the same plug. It's just if you plug the wrong one in, your front port audio isn't going to work. There is a pin missing on the plug to ensure that it only goes on one way. And on most motherboards, the connector is all the way back on the bottom left side. And with this motherboard, it is. It's located right down here. So again, I have run this cable through the bottom wire grommet, separated away from these flat cables. And I'm going to run it underneath all the other cables since it's got to go that distance. And just orient it in the proper direction and plug it straight on. Now, in the cables that remain, you will find one set of cables that once again are terminated differently than all these other cables. All these other cables have power connectors on them. And this just has your standard 2-pin plugs on them. And that's our reset switch, our power switch, and our hard drive LED. Now, most cases also have a power LED wired to go to the front of the case. This case does not. It's providing power to the power LED a different way, which, once again, I'll show you when we get there. But I'm so glad to get to this part because now I get to show you that quick disconnect that Asus includes and why I think every motherboard should include this. In the motherboard box, Asus included these quick disconnects for the front I/O and for the case USB 2 ports. If, you know, in older cases, they used to just give you the wires and you had to put each wire on the USB 2 in the right order. I haven't seen that in a long time, so we won't be using this blue one. Now, personally, I think every motherboard should include these quick disconnects because they make hooking up the front port cables so much easier. You'll see this side of it is for a speaker and the power LED. We're actually not even going to use this side. If we turn it around, you'll see it's labeled for the hard drive LED, the power switch, and the reset switch. And so all we need to do is take the hard drive LED, and where there's a positive on this quick disconnect, there's also a positive and negative labeled on the connector. And the connector is just going to go on those 2 pins. Just like that. Now, the power switch and the reset switch do not have a positive or negative, so it doesn't matter which way you put them on. And I'll just put the power switch on next. And again, you'll see how that's labeled. Power switch with the power switch connector on it, and a reset switch, which goes on the last set of pins there. Now you'll see this connector has holes in certain positions so that it only plugs in one way on the motherboard, which is actually going to be this direction. So here on the bottom right corner of the board is a large white connector. That's where our hard drive LED and switches and such go. And instead of hooking them up individually, we just use this large disconnect that we hooked up and plug it straight on. All right, at this point you might be saying, hey, that's all well and good, but you still have a lot of cables left over. Actually, we don't. A lot of these cables are for powering an LED. And since we're not hooking up any LEDs on this case, I guess some fans have separate LED power connectors, and I'm not exactly sure, without doing the research, where these LED power cables come into play, but we aren't using them. So all these cables that have these 2-pin power connectors here on the end, every one of these is not being used. So what we can do is gather them all together. We can actually push them out the back of the case. Now, as you can see, our bundle of cables has gotten a lot smaller. If you look closely, you'll see 2 of these cables are power cables for the removable drive trays. And the rest of these are fan headers, with the exception of one more power cable right here. But instead of having them come out up here, I'm going to reroute these. We'll push them out the back, and we're going to bring them in down here on this lower tray, since we've made this available, because we can hook up the front fan. And I'm going to go ahead and take the fan I removed from the top when I installed the water block, and I'm going to go ahead and move that up here on the front. You'll see there's a space for a fan. We've got it. It really doesn't need it there, but we'll go ahead and put it there, and then we can hook those cables up here. So out of all of these cables, we're actually only going to be using 3 more of these. So let me get these pushed out and redirected down here. All right, now that I've got the remaining cables routed down below to this bottom compartment, now would be as good a time as any to go ahead and put that other fan in. And that's real easy to do on this case. We just rotate that around and we'll raise the cover up. This bottom piece here, you can actually grab it from underneath and pull it towards you, and it actually will unclick from the bottom and slide out from the top, and we can set that down. And I'm going to take the fan that I removed that was up here on the top, and I'm going to place that here. Now when I install this fan, I want to make sure it's drawing air into the case. All front fans bring air in, all rear fans blow air out. So again, using the same rule I showed you earlier, the center part that spins, that's the part that's drawing the air in. The center part here that doesn't spin, that's where the air is coming out. So we're going to put it in this direction and very easily reach that part right now. And I'm going to use the exact same screws that I removed when I took the fan out. And we just need to line the holes up here. Now that I have the screws started, my screwdriver is actually cutting off a little bit early because these are a bit tighter to get into the fan. And I don't want to adjust the clutch to be too strong. So what I'm going to do is lock the screwdriver so that I can turn it like a mechanical driver. Make sure that I don't over tighten these screws. Then we can take our cover. You'll see it's got 2 notches on the top. Slide the top in first and then push the bottom in. It will click into place. And installing that fan is really just that easy. Now on these power connectors that remain, these actually go to the fan controller that's up here on the very top of the case, which once I get the system running, I'll show you how that works. But we only are going to hook up 2 fans effectively. We have the front fan, and because there used to be hard drive cages here, this is called a hard drive fan. And you'll see there's little labels on all of these cables. And this one is labeled FRO fan, so that's front fan. And all I have to do is take the power connector coming off of that front fan and plug it right into that connector. The remaining cables are actually 3 hard drive fan connectors, 3 top fan connectors, and 2 GPU fan connectors. Now, the GPU of course has its own fan, so these are referring to the fans that you can optionally put on the side panel of the case. It has room for 2 fans. That's why there's 2 GPU fan power connectors. They blow right over the GPU with the graphics processor. We're not using those 2. Then we've got 3 top fan connectors, which are right here. Remember, up on the top there was room for 3 fans. There was 1 there with 2 empty holes. We removed the 1, replaced it with the fans on the radiator. The radiator controls these fans. We're not using any of these 3 top fans, so those get pushed aside. What does that remain? We've got a hard drive fan, and a hard drive fan. Why are there 3? Remember, there was 2 fans sitting right here, so that's 2. Plus the 1 we added, that's 3. That covers the 2 hard drive cages that used to be here. So guess what? We are only going to use 1 of those, 1 of the HDD fans. And the reason why it's important is when you use your fan controller to know which fan you're speeding up or slowing down. Because if you've got them connected to the wrong ones, you're going to hit the button to slow down or speed up your HDD fan, and instead you're going to speed up your other fan. So, I mean, they're all going to work just the same, but that's why they're labeled. And the fan connector plugs in exactly the same way. 3-pin fan connector into the 3-pin plug. And all that remains after all of that is a power cable, which we'll hook up. That's actually, when we hook power to this, what's going to light up the power LED and power the fan controller and power all the fans right here on this 1 connector. So the rest of these can be tied up and hidden because they're not going to be used. And that is all of our cables except our power cables. So next we can go ahead and install our video card. Now, one of the beauties of shooting in HD is that some of you may have noticed that there is a power cable connected way up here at the top that I never showed how to do. And the reason for that is I did some testing off camera yesterday with the system. And I tried to return the system back to the state it was in, and that's an oversight on my part. So let me take it out. We'll pretend like that wasn't there, because I haven't shown you how to plug that in yet. So let me just take that out of there. And that didn't happen. See, the alternative is that I would have to reshoot everything I've already just shot over a simple mistake like that. So I'm going to be taking the easy way out of it, and we'll just pretend that never happened. Now, where was I? Ah, yes, installing the video card. Finally. All right. Now, when we install a video card, you'll see we've got several sockets the video card will actually fit in. But if you've only got one video card, you're going to want to plug it into the topmost socket, very top one up here. And you'll see the end of these sockets actually have retaining levers that move back and forth, very similar in function to the memory retaining levers. And here's the thing. If that retaining lever is closed, you could break it if you try and force your video card in anyway. So take a moment now and move that top retaining cover, or retaining lever rather, over to the side so it's in the open position. Then we're going to grab our video card, and again holding it here by the plastic shroud, and I'm going to hover it over that port just to see which of these back cover plates here I've got to remove, these expansion bay covers. So I can see when I line it up, I've got to remove the second and third cover. So let me do that right now. Next, I'm going to take the video card. You'll see it looks like it's in upside down. The circuit board face is up, the fan face is down. Line up the groove in the connector here with the groove on the connector on the board. And we're just going to line that up. Again, making sure that retention lever is in the open position. Don't try putting any force on the card until it is lined up correctly with the slot. Once you're sure that that's lined up correctly, just push it straight down, and you may even hear that retention lever click. There it goes. Now I'm going to take the two thumb screws I just removed that were holding in these expansion bay covers, and we're going to put those right back in to secure that video card. Now these expansion bay covers I'm going to throw into the motherboard box with the rest of the spare parts. They might be needed in the future, you never know. And all we have left now is to hook power up to everything. All right, we're in the final stretch of our build almost being completed here. All that we have to do is hook power up to everything, and then we can test fire it, make sure that it does a power on self-test. It can't boot to anything because the hard drives are brand new, they don't have any partitions. That's okay. It should say no bootable media found or no bootable device found, something along that lines. That way you know you're on the right track. You need to at least get that post or power on self-test. Once that's done, you'll have a final opportunity to make any other changes to the case. If you want to move fans or move drives around or change cages, there's a lot of options here, and you got to think about what's going to fit your needs now and in the future the best. Once you've made that decision, you can do your wire management. Then you can go ahead and update the motherboard BIOS if you want. Go ahead and install the operating system, download all the updates to the operating system, install all your drivers, and make sure you get all the latest ones from that, from the manufacturer's website. Also, the solid state drive has firmware. You want to make sure you've got the latest firmware on the solid state drive, which you'll do after you get everything installed on it. And then finally, you can put the covers back on it, and we can run some performance numbers on this big old beast and see what it looks like. But the end starts now with the power cables. Now here's a close-up of all the modular cables that are included with the SeaSonic 1250XM power supply, not the least of which is the main power cable. Holy moly, that thing is huge. Look how thick that is. It's probably the most heavy-duty power cable I've seen on a PC in a long time. But I suppose it has to be if you're going to be drawing as many amps as that power supply can deliver. We're not going to be drawing anywhere near that on this system, but he certainly has room to grow, that's for sure. Then all these other cables, I've just got them grouped together in what they do. So for example, this is our main motherboard connector. We've got a 12-pin CPU power connector and an 8-pin CPU connector. We will not be using the 12-pin, that one goes away. Here we've got regular Molex and SATA connectors for hooking up our data drives. That's what all of these are. We're not going to be using all these. And then these last set of 4 are power cables for video cards. And we're not going to be using all of these. We're actually probably just be using one set since we're using one video card, and then these 3 can also go away. So those will get put away for future upgrades. And then, like I mentioned, some of these Molex connectors, I don't know which ones of these I'm going to use. I'm not going to use all these. Some of these are going to get put away. And we're going to find out which ones right now. Now the first connector out of that bundle that remains that we're going to use is this largest connector of the bunch. You'll see it's got one end, it's got this 24-pin connector, and the other end is split into 2 connectors here. The split end is what's going to go onto the back of the power supply, and this large end is going to go on the very large connector on the motherboard. We'll start by taking the large 24-pin connector on this end of the cable, and it's going to plug into the large blue 24-pin connector located up here on the top right. The little clip on this connector, in fact in all the connectors you should be hooking up to your motherboard, face towards the edge of the board. It can only go on one way, so it's not like it's possible for you to put it on backwards, not without physically using so much force you break it. And just simply line it up, and you should hear it click into position. We'll take the other end of this cable and we're going to route it through the back. And now from behind the motherboard, you see I've got the cable right here. I'm going to bring it down through the power to the power supply. And this is going to be a little difficult to film because these support braces are in the way of the camera. But let me give you the best shot I can of how these cables plug in. The clips on the connector face down, and we're going to plug the largest of the 2 connectors here on the bottom connector. And the connector says M/B, which is short for motherboard. So we plug that one in. And then the smaller cable plugs in directly above it in the other connector also labeled M/B. And again, with the connector facing down. Now the next cable we're going to need is the CPU power connector, and that's got an 8-pin connector on each side, and one of them is split into 2 4s. This side that's split into 2 4s goes towards the motherboard. Some motherboards have a 4-pin connector, some have an 8. This board has an 8, the board we're using today. And then the solid connector that does not split, that says CPU on it, is going to plug into the back of the power supply. So the split ones are the ones we're going to deal with first here on this end of the cable. The clip is going to face the outside edge of the motherboard into this other blue connector located right here. And we can just plug that straight on, and you should hear that click into position. Now the other end of this cable, the end that says CPU on it that I just showed you, is going to go on the back of the power supply on the connector next to the top motherboard connector we just plugged in, and it actually is labeled CPU. And again, all the connectors on the power supply face downward. So going back to the modular cables that came with the power supply, we want one of the cables that looks like this, where it's got a 12-pin connector on one side. This is the part that goes to the power supply. And then it breaks off into 2 separate cables, as you can see here. And they're both labeled PCI-E, and then they have an optional 2 additional pins that can connect on. Now it doesn't matter which of these connectors you use on these plugs. All that matters is you've got them configured properly. In other words, there's this extra little 2-pin power plug that connects to make a 6-pin plug into an 8-pin plug. And you'll see we've got a 6-pin connector and an 8-pin connector. So as long as you've configured the plug to have the right amount of pins, it doesn't matter which one you use on which plug. Typically it's best to start with this bottom connector. In this case it's a 6-pin connector. So I'll go ahead and bend the extra 2-pin one away. And with the clip facing up, it'll plug straight on. And now we can do the top connector with the clip on the plug facing down. And you usually have to kind of squeeze the extra 2-pin on it, otherwise it'll want to separate on its own. It's only going to fit in one way, and again you'll hear that click into position. Now take the other end of this cable, and this is where you have a little decision making to do. We've got a lot of places that we can run this cable for cable management. It really depends on what you think looks best. You can choose to run it, if you want, you can run it straight down, for example here or here, and bring it through directly to the power supply, and you'll see how that's going to look if we do that. Or what I personally think looks better is to run it up here by the big main motherboard power connector and just push that out towards the back, and it kind of keeps our cables all together. Whether or not you think that looks better or not, some people will, some people won't. But if it was my computer, that's how I would run it, unless the cable wasn't going to reach. So if there's a distance problem, you may be forced to route the cable a certain way. But those are the considerations that I take, and you should, when you're hooking your cables up. And it's best to do it now, otherwise you'll have to redo it later. Now the rest of the power connectors that are along the top of the power supply, those are all for video cards. And since we're only using one video card, we only need to use any one of those 3 connectors up there. So I'm going to go ahead and plug this cable in next to the other cables we've got to keep all the cables together for cleaner wire management, and also have easier access to the available ports if we add a video card in the future. Now to give power to our 3 hard drives, we're going to need 3 SATA power connectors. So looking at the modular cables that came with the power supply, it just so happens SeaSonic gives us a cable that has exactly 3 SATA power connectors on it. So here's a close-up of the back of our drives. Now what you need to consider if you're going to be using one power cable, as I am here to power all 3 drives, is that these connectors only go on one way. So for example, if I start with the end connector and I put it on the top drive, that means this connector is now upside down, and I have to flip it around, so the cable has to, effectively the bottom cable now has to bend up to the top. You see what's happening there? In order for that to fit on. And it just looks ugly. With just a little added effort, not much effort, take the same cable that you would have used on the top, instead put it on the bottom. Now the bottom of the next connector is going to stay the bottom. It doesn't have to flip around. It'll just plug straight in, and the same thing applies for the final connector on the last hard drive, and it's just a much cleaner look. Now we take the other end of this cable, and the cable management for it is basically nothing. You just run it under here right to the back of the power supply, and it'll plug in any of the remaining 6-pin connectors on the back of the power supply. This isn't wire management, by the way. This right here was just me getting a zip tie real quick to get these wires out of the way so I could get you an angle on this with the camera that wasn't a big curtain of wires where you wouldn't be able to see what I was doing. So that's going to be cut away here in just a minute, but that was just done for this shot. There are a lot of people who watch every detail of these videos, and you might be one of them, and you might be thinking, is that his cable management? No, it's not. So here's a close-up of me plugging the SATA power cable into the back of the power supply. Any of the remaining power connectors on this row here you can use. I just want to keep all my cables together. Finally, the last power cable we're going to need is to power the external drive bays. If they're used, they're going to need power, and the fan controller. And they all use these what's called Molex power connectors, and we need 3 of them. And wouldn't you know it, SeaSonic gave us exactly 3 on this one cable. What's great about that is that we're running fewer cables that way. There's really no limit to how many things you can plug into one cable, and unless you have an exceptionally unusual system. If the cable fits, you can use it regardless of whatever else it's plugged into. So locating the Molex connectors is quite simple. There's one coming out of each of the external drive trays. And then there's one coming down from the top of the fan controller, which also provides our power LED. So to keep our cabling as clean as possible, I'm going to go ahead and push these through to the back. So we'll hook that power up where it is going to make our cables look as clean as possible. Now, as you can see, our cabling is getting to be kind of messy back here. But this is why it's important to take your time now when you're hooking up cables, that you route them without going between cables that you're going to have to undo later when you do your cable management. So just take a few extra minutes now, first of all, to find the darn cable you need, which we've got the one power connector here, the other power connector here, and there should be another power connector. There it is, right here. So you see how these are coming out here and this one's coming out through the bottom. It's just really a matter of thinking through how your cabling is going to look. And it doesn't mean you have to get it right the first time. If you don't, you just have to redo it and and redo it until it looks good to you. These connectors only go on one way, and it doesn't matter which connector you use onto which plug. There's no order to it. And we'll go ahead and just plug both of the external drive bays in first. And then this last connector, like I said, if this is going to run, if I'm going to have this tied up, I have to consider, I don't want this cable to be on the outside. If they're all going to be on the inside, then this one has to be inside of that cabling too. And then we'll just take that one last power connector, plug that right on, and the other end of this cable is going to plug in right next to the last one we plugged in. Now there's just one last power cable we've got to hook up. Didn't I already say that? Well, I almost forgot about hooking up the optical drive and the water block. We better hook those up, don't you think? So the SeaSonic power supply actually comes with the exact cable we need that has two SATA connectors on it, but it's not long enough to do the cable management I want to do. So the longer cable has 3 SATA connectors on it. We're only going to use 2 of them, but it's going to make the cabling look a lot better. So I'm going to start by taking the very end of this power connector, using the end SATA power connector, and I'm going to plug it right onto the back of the optical drive. The rest of the connector, I'm actually going to feed right through the cable management hole, all the way through. Now, to keep our cabling as clean as possible, I'm going to take the SATA power connector from the water block, and I'm also going to feed that one through this hole in the very top back. So that power connection is going to happen behind the board and keep this area as clean as possible. So here's the power cable I've just pulled through, and here's the SATA power connector coming off the water block. And this one's a little bit tight if we want to use this power cable, which we can. We don't have to. If it's too tight, we can switch over to this one. Again, we want our cabling to look as nice as possible. I think that's going to be okay. And then we can run this right down and into the back of the power supply. And just like the last cable, this one's going to plug in right next to it. Now, one of the things that I've just noticed is that this large front fan right here actually does have a small 2-pin power connector which will light up the LED on it. And here I thought we weren't going to use any of these little 2-pin power connectors for LEDs, and they're not labeled for any specific fan. I've actually never encountered this before. Usually on all the fans I've used, if they've got LEDs, they're powered with the same power as the fan, and when the fan speed slows down, the LED light dims. It gets less bright. So apparently these don't work that way. At least that's what it seems. But it doesn't matter which of these you grab. Since they're not labeled, they don't have to be. They're all going to provide power equally the same. And this is the only fan we've got that's got that connector. And these two just go together. It's got a groove on one side and a notch on the other. So it can only fit in one way, and it will just click right into position. Now we're ready to turn on the system for the very first time and see if it boots. It's time for the moment of truth. I've got out my monitor, my wireless keyboard, and my wireless mouse. These are the only things we're going to be hooking up to the computer. When you're doing your very first power on, You don't want any unnecessary items plugged in, such as a flash drive or a printer, even the internet. Don't plug any of that in yet. So here I've got the wireless USB receiver for the mouse and the keyboard. I'm going to go ahead and plug those into the back of the machine here on the black USB 2.0 ports all the way at the top. Although any of the USB 2.0 ports should be fine. It's a good habit to get into to use the topmost ports. Now, the next thing I'm going to hook up is the monitor. A lot of people ask me, why do you always hook up the DVI cable on your monitor? Because that's what's convenient. The video card on the back of this computer, and perhaps maybe even on the back of yours, will have multiple connections on it. This one's got 2 DVI connections, it's got an HDMI connection and a DisplayPort connection. If I had an HDMI cable coming out of this monitor, I'd grab it and plug it in. It's just whatever's easiest. So they'll all work equally the same. There's no specific reason why I'm using the DVI cable when I'm doing a power on self-test or checking a system, other than that's the first thing that's available to me to grab. So on the back of the video card, as I previously mentioned, it's got 2 DVI connectors. One's a DVI-I and one's a DVI-D. Doesn't matter which one you use. I'm going to use the DVI-D. I've just removed the protective cover from the back and plug the monitor right in there. Now, the very last thing that we hook up is the power cable. Make sure your power supply switch is in the off position. We'll go ahead and plug the power cable in, and once that's firmly seated, flip the power supply switch to the on position. Okay, no sparks came out. That's a good start. So now we're ready. I don't even know if I can reach the power button from back here. But there's a lid that's got to slide back. Let's see if I can reach it. And if I can feel it, I think the power button's right there. Yeah, I can hear it. So what we're hoping to see is something about no bootable device, something like that. And it should happen pretty quickly with a system of this caliber. Initially you hear the fans are pretty fast, and then they slow down because they calibrate. And there it is, no bootable device found. Now what I'll do next is configure the RAID array and install Windows 7 onto the solid state drive along with all the updates and get that optimized. There's already a video detailing how to install Windows 7. I'll be following that video exactly, and a link to that video will be in the video notes below. I'll also clean up all this cabling, and then I'm going to come right back and we'll run the performance numbers and see exactly what this machine can do. Alright, so I've got the operating system installed, our cable management is done, and there's just one more thing I want to do. If you recall, these 2 fans were removed because we're not going to use them. Well, actually, we can use the fans. I'm going to go ahead and remove the fans and mount them onto the side panel. The side panel has an area for mounting up to 2 fans that can blow directly over this video card. This video card can get really, really hot, and it will, especially when video rendering. Now to remove the fans from this mount is actually very simple. They're not screwed in, there's just little plastic clips. If you can see these here on the camera, if I push that clip away and lift up on this fan, you'll see it will easily come out. There's a clip on the opposite side that also has to be pressed in. And you'll see that the cable is run right along the edge here, which will be a lot easier to get out once we remove the other fan, which is the same thing. One clip on one side, one clip on the other. This can be put away, and we can go ahead and mount these fans now onto the side panel. Now this side panel is much different than any other side panel I've seen on any other computer case. The way we mount the fans on this is, you'll see there's a couple of Phillips screws here we've got to remove. Looks like we've got 3 of them. One here, here, and here. You'll see there's an arrow that's pointing to this direction. You slide the cover that direction, and the whole cover just comes right off. And our fans are going to mount on the other side, but we're going to put the screws in from the inside. Now to mount the fans onto this, I actually have to turn it around so you have the right perspective. This is the inside of the door. This is what's going to be closed and facing the computer, the parts. And what we're going to do is put the fan in this direction, this way, so that the center part that doesn't move is going to be bringing air into the case, drawing air in from the outside. But what you've got to consider is the length of your power cable, because once you get this hooked up, it may limit the ability of opening that door without an extension cable or making your cabling not look as good. You can also buy fans that have a protective shield over them to keep your fingers from getting in there. Again, this is the side of the door that's going to be facing the inside of the computer. But this is how it's going to mount, and we just have to put the screws in from this side. That's why we had to take it off. Now I should also mention, when you're putting your fan in, you should pay attention to where the power cord is going to be coming out, because remember, this door is going to swing open. So you can see now that I've got the power cord coming out what's going to be the bottom, so that when this is put back into place, that we'll be able to swing the door open. This is the hinge side of the door. We're going to go ahead and put this other fan on right here in exactly the same manner. In fact, we can either put it on this way or we can do it the exact same way. The problem is going to be one cable will end up more than likely being shorter than the other when the door opens. So you got to think about that when you're putting these fans together. This will be probably the closest to having the same cable length, even though one's going to look sideways compared to the other. You might go for the look, but no one's going to see this unless the door is open on the case anyway. So I'm going to go for cable length. Now with both fans mounted, we can go ahead and set that back into it's got a little groove that it sits in, and then it slides back into position, and we'll put these 3 screws back in. All right, so now I'm going to take our door. It's ready to go. You've seen how this goes on before. We've got the little notches that stick out. They're going to slide into the groove, and it just slides down into position. And you can see how our cables here on the fans are going to limit the opening of this door. So it's certainly something to consider if you're going to put fans on the door. Now I'm going to take the 2 fan headers here that say GPU fan. It doesn't matter which one you use. That way they will be controlled from the fan header on top of the case. And we'll plug each one in. And now, you know, we can't really do much cable management there. We can't tie that up, because if we do, we won't be able to open the door. So we'll go ahead and just watch the cables when we close the door, and that panel's on. Now here you can see the cable management on this side. It certainly isn't the prettiest cable management job, but there are a lot of cables here. So it won't interfere with the closing of the door, and it's really easy to have to work on anything since the cables are separated into sections. That's the logic behind it. And again, this door is going to go on exactly the same way, onto the hinge. And sometimes you have to just kind of smack it down, get it seated, and then we can go ahead and close that door. So here's the completed monster, all done. Looks pretty much the same as when we took it out of the box, doesn't it? Let me show you how the fan controller works. Now here's a view of this case you don't often see, from the top down. If we slide the top back, this is the fan controller, and this is where a power switch, power LED, hard drive activity LED, and the lights that are lit up here, like this says HDD. That tells us we have an HDD fan attached. The GPU is referring to the GPU fans that we've attached to the side door. LED is the front LED that we hooked up on the front of the case. We can turn that on and off with this switch. Our main power button is here. Again, power LED is here. Hard drive activity LED is here. Reset button is here. Top is not lit up because the top fans are controlled by the H100i. And then the front fan is lit up because obviously we have the front fan. When the lights on the fan controller are blue, that's signifying that it's in low speed mode. If you push the button, you'll see the light goes to purple. That's medium speed. And then red, that's high speed. So you can adjust the speed individually of the fans. You can put them all on high right now. And of course the machine's going to get just a little bit louder when you do that. Then we can go ahead and just put them right back onto low. And that's all there is to that fan controller, and that's how that works. Now let's take a look at the performance numbers of the computer, starting with the RAID 0 array. Just want to focus on those top numbers. We've got read speeds of 292.8 megabytes per second and write speeds of 179.4 megabytes a second. Now compare that with the solid state drive, which has an amazing 516 megabytes per second and 300 megabyte per second write speed. Now, the Windows Experience Index on Windows 7 shows the maximum 7.9 subscore on every single component except the processor, which gives us a base score of the lowest subscore, which is 7.8. Now, just for grins and giggles, I threw Windows 8 on it, and you'll see the individual scores there with the base score is 8.1 on Windows 8. Now, what about Windows 8.1? Who knows? The Windows Experience Index has been removed from Windows 8.1. And ironically, our base score is 8.1. Go figure. Well, I hope you enjoyed this video. If so, please click the like button and be sure to hit subscribe if you want to be made aware each time a new video of mine is posted. Thank you for watching, and I'll see you next time. Bye for now.